Hi students. Welcome to Smart Tricks for Today channel. ಪಾರ್ಟ್ ಬಿ ನಲ್ಲಿ ಬರುವ 1 ಮಾರ್ಕ್ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಯಶಸ್ವಿಯಾಗಿ ಮುಗಿಸಿದ್ದೇವೆ. ಇಂದಿನ ವಿಡಿಯೋ ನಿಮ್ಮ ಪರೀಕ್ಷಾ ತಯಾರಿಯ ಅತಿ ಮುಖ್ಯವಾದ ಘಟ್ಟ, ಯಾಕಂದ್ರೆ ನಾವು ಇವತ್ತು ದ್ವಿತೀಯ PUC ಮಾಡೆಲ್ ಪೇಪರ್ ಸೆಟ್ 1ರ ಪಾರ್ಟ್ ವಿಭಾಗವನ್ನು ಶುರು ಮಾಡ್ತಿದ್ದೇವೆ. ಇಲ್ಲಿ ಬರುವ ಪ್ರತಿಯೊಂದು 3 ಅಂಕದ ಪ್ರಶ್ನೆಗಳು ನಿಮ್ಮ ರಿಸಲ್ಟ್ ಅನ್ನ ಬದಲಾಯಿಸುವ ಶಕ್ತಿ ಹೊಂದಿವೆ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಕೇವಲ ಪ್ರಶ್ನೆಗಳನ್ನಷ್ಟೇ ಅಲ್ಲ, ಎಕ್ಸಾಮ್ನಲ್ಲಿ ಪೂರ್ತಿ ಅಂಕ ತಂದುಕೊಡುವಂತಹ ಪರ್ಫೆಕ್ಟ್ ಉತ್ತರಗಳನ್ನು ಪಾಯಿಂಟ್ಸ್ ವೈಸ್ ನೋಡೋಣ. ನೀವು ನಮ್ಮ ಚಾನೆಲ್ಗೆ ಹೊಸಬರಾಗಿದ್ರೆ ಅಥವಾ ಇನ್ನೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಈಗಲೇ ಆ ಕೆಂಪು ಬಟನ್ ಒತ್ತಿ. ನಿಮ್ಮ ಈ ಒಂದು ಸಬ್ಸ್ಕ್ರಿಪ್ಷನ್ ನಮಗೆ ಇನ್ನೂ ಹೆಚ್ಚು ವಿಡಿಯೋ ಮಾಡಲು ಸ್ಫೂರ್ತಿ ನೀಡುತ್ತೆ.
Let's start. Part C. Answer any 5 of the following questions. Each question carries 3 marks. Question number 29. Next. Expression for the torque, couple, acting on an electric dipole placed in a uniform electric field. From the figure. Consider an electric dipole placed in a uniform electric field, E. Let plus Q and minus Q are two charges of dipole. P is dipole moment acting from minus Q to plus Q. 2A is distance between two charges. Theta is angle between the directions of E and P. Therefore, force acting on plus Q is F is equal to QE. Along E, force acting on minus Q is F is equal to minus QE, opposite to E. These two forces, that is F plus Q and F minus Q, are two equal and opposite force acting on the dipole. As a result, torque is acting on the dipole. Therefore, torque is equal to magnitude of either force into perpendicular distance. That is, τ is equal to EQ into BO. Mark it as equation number 1. To find BO, from triangle BOA, sin theta is equal to BO by AB. Therefore, BO is equal to AB sin theta. But AB is equal to 2A. Therefore, BO is equal to 2A sin theta. Mark it as equation number 2. Now, substitute equation 2 in equation 1. We get τ is equal to EQ into BO. That is, τ is equal to EQ into 2A sin theta. But Q into 2A is equal to P. Therefore, τ is equal to EP sin theta. This is the expression for torque acting on the dipole. Vector form of torque acting on electric dipole moment. Vector τ is equal to vector P into vector E. Next. 30. What is a capacitor? Mention any two factors on which capacitance of a parallel plate capacitor depends. Answer. Capacitor is a system of two conductors separated by an insulator to store electric charge and electric energy. Capacitance of parallel plate capacitor depends on 1. Directly proportional to the area of each plate. 2. Inversely proportional to the distance between the plates. 3. Directly proportional to the dielectric constant of the medium between the plates. Next. 31. In a chamber, a uniform magnetic field of 6.5 into 10 to the power minus 4 Tesla is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power 6 meter per second normal to the field. Determine the radius of the circular orbit. Given, E is equal to 1.6 into 10 to the power minus 19 coulomb, and ME is equal to 9.1 into 10 to the power minus 31 kilograms. Answer. Given. Magnetic field strength, B is equal to 6.5 into 10 to the power minus 4 Tesla. Speed of the electron is equal to 4.8 into 10 to the power 6 meter per second. Charge on the electron, E is equal to 1.6 into 10 to the power minus 19 coulomb. Mass of the electron, ME is equal to 9.1 into 10 to the power minus 31 kilograms. Therefore, magnetic force exerted on the electron in the magnetic field is given as F is equal to EVB sin theta. Angle between the short electron and magnetic field, theta is equal to 90 degree. So, this force provides centripetal force to the moving electron. Hence, the electron starts moving in a circular path of radius r. Hence, centripetal force exerted on the electron, Fe is equal to mv square by r. In equilibrium, the centripetal force exerted on the electron is equal to the magnetic force, that is, Fe is equal to F. Substitute values in above equation, we get mv square by r is equal to EVB sin theta. Now, equate to r. Here both we get cancelled, so we get r is equal to mv by be sin theta. Therefore, r is equal to 9.1 into 10 to the power minus 31 kilograms into 4.8 into 10 to the power 6 meter per second by 1.6 into 10 to the power minus 19 coulomb into 6.5 into 10 to the power minus 4 Tesla into sin 90 degree. Here, sin 90 degree is equal to 1. Therefore, on simplifying, r is equal to 43.68 into 10 to the power minus 25 by 10.4 into 10 to the power minus 23. That is equal to 4.2 into 10 to the power minus 25 plus 23. Therefore, r is equal to 4.2 into 10 to the power minus 2 meter. Also we can write as r is equal to 4.2 centimeter. Hence, the radius of the circular orbit of the electron is 4.2 centimeters. Next. 32. Mention any three properties of magnetic field lines. Answer. 1. Magnetic field lines form continuous closed loops because they emerge from the north pole of a magnet and enter the south pole, returning through the magnet's interior. 2. No two magnetic field lines intersect because, if they did, the field would have two directions at the same point, which is impossible. 3. The density of field lines represents the strength of the magnetic field because closer line have strong field and wider spacing have weak field. 4. Field lines are denser near the poles because the magnetic field is strongest at the poles of a magnet. 5. Outside the magnet, field lines travel from north to south. Inside, they go from south to north. 6. Magnetic field lines exert lateral pressure on each other. This is why they tend to spread out sideways and repel each other. 7. They show the direction of the magnetic force on a north test pole. Next. 33. Describe the coil and bar magnet experiment to demonstrate the phenomenon of electromagnetic induction. Answer. The arrangement consists of a coil, C1, with a galvanometer, G, and a bar magnet as shown in figure. When a magnet is moved towards a coil, the galvanometer attached to the coil shows deflection. On one side, this indicates that electric current is induced in the coil. When a magnet is moved away from the coil, galvanometer shows deflection but in opposite side, which indicates reversal of the current's direction. When there is no relative motion between the magnet and coil, the galvanometer shows no deflection. It shows that there is a production of current, EMF, in the coil when there is a change in magnetic flux. Next. 34. Draw the ray diagram for the formation of image by a compound microscope. Write the expression for linear magnification produced by the objective of compound microscope in terms of its tube length. Answer. Diagram of compound microscope, as shown in figure. Where AB is object. A dash B dash is intermediate image. A double dash B double dash is final image. U is object distance. D is image distance. F naught is focal length of object. FE is focal length of eyepiece. L is length of tube. Here, compound microscope has two lenses. The lens nearest to the object is called objective. The lens nearest to the eye is called eyepiece. Objective is a convex lens of short focal length and small aperture. Eyepiece is also a convex lens but of large aperture and large focal length. When the object AB is placed at a distance greater than the focal length of the objective, a real inverted and magnified image A dash B dash is formed. The position of the eyepiece is adjusted such that A dash B dash lies within its principal focus. Hence A dash B dash serves as object to form a final image A double dash B double dash, which is virtual, erect enlarged image. Therefore, magnifying power of a compound microscope is M is equal to M naught into ME. That is equal to L by F naught into bracket D by FE. Where F naught is focal length of object. FE is focal length of eyepiece. L is length of tube. D is least distance of distinct vision. Next. 35. What are matter waves? Explain the de Broglie hypothesis of matter waves. Answer. Matter waves are waves associated with moving particles of matter, such as electrons, protons, atoms, etc. They are also called de Broglie waves. Explanation. De Broglie hypothesis of matter waves. A French physicist Louis de Broglie suggested that the particles like electron, protons, neutrons etc. have also dual nature, i.e., the material particle can behave both wave as well as particle. According to quantum theory, the energy of a photon is given by E is equal to h nu. That is equal to hc by lambda. Mark as equation 1. Where h is a Planck's constant. Nu is the frequency of a photon. According to Einstein's mass-energy equivalence, the energy of a photon is E is equal to mc square. Mark as equation 2. From 1 and 2, we have hc by lambda is equal to mc square. Here c get cancelled. Therefore, h by lambda is equal to mc. Therefore, lambda is equal to mc by h. Since mc is equal to p, where p is momentum of photon. Therefore, lambda is equal to p by h. Next. 36. Differentiate between nuclear fission and nuclear fusion. Answer. Nuclear fission and nuclear fusion. 1. Nuclear fission. It is a heavy nucleus splits into two or more lighter nuclei. Nuclear fusion. It is two light nuclei combined to form a heavier nucleus. 2. Nuclear fission requires low energy, that is moderate temperature to start. Nuclear fusion requires very high temperature to start. 3. Nuclear fission releases large amount of energy. Nuclear fusion releases much larger amount of energy than fission. 4. For nuclear fission, example, splitting of uranium-235, plutonium-239. For nuclear fusion, example, fusion of deuterium and tritium in the sun. 5. Nuclear fission produces radioactive waste. Nuclear fusion produces very little radioactive waste. 6. Nuclear fission occurs in nuclear reactors and atomic bombs. Nuclear fusion occurs in stars like the Sun and hydrogen bombs. In the next video, we study 5 marks questions with answers. Don't forget to subscribe the channel for more.